Imagine receiving a postcard from a friend sent from a faraway and exotic land, a tangible piece of their journey delivered right to your doorstep. But what if, upon closer inspection, you find the image blurry and indistinct? Tilted at an awkward angle and shrouded in a thick, impenetrable haze, the message becomes obscured, the beauty lost. This is akin to what scientists experience when they first receive raw satellite images, a tantalizing glimpse from above, messages from space carrying invaluable data, but not immediately clear, understandable, or useful. The information is there, but it's buried beneath layers of distortion. These images are inherently warped by the Earth's curvature, a fundamental geometric challenge clouded and obscured by the ever-present atmosphere, which scatters light and introduces unwanted artifacts, and speckled with electronic noise, the digital equivalent of static, interfering with the clarity of the signal. At first glance, the crucial details are hidden, the valuable information locked away, seemingly irretrievable. The real challenge, therefore, isn't just capturing these images from hundreds of kilometers above, but translating them into something meaningful and actionable for us down here on Earth. We must meticulously remove geometric distortions, correcting for the Earth's curvature and the satellite's viewing angle. Clear the atmospheric haze, filtering out the unwanted effects of light scattering and absorption, and silence the electronic noise, employing sophisticated algorithms to smooth out the data and reveal the true underlying signal. Without this crucial step, comparing images across different seasons or years or even different satellites would inevitably lead to inaccurate and potentially misleading conclusions about the state of our environment. The raw image is just the beginning, a complex and intricate puzzle with countless pieces scattered across the digital landscape, waiting to be carefully assembled. Scientists must patiently coax out the hidden truth, methodically and carefully piecing together the fragments of information. This is precisely where the power of digital image processing comes into play, the essential key to unlocking the full, transformative potential of satellite data, allowing us to see our world with unprecedented clarity. It transforms what was once a confusing and distorted glimpse into a clear, vibrant, and informative portrait of our ever-changing world. To truly appreciate the power of image processing and its incredible potential, we must first understand the fundamentals of satellite remote sensing. It's the foundation upon which all image analysis is built. It's the science of observing our planet from afar, a vantage point that offers unparalleled perspective, much like our eyes, but on a global scale, constantly monitoring and recording changes across vast landscapes. Satellites orbit high above, circling our planet in carefully calculated paths, equipped with sophisticated sensors that see far beyond the limits of human vision, into the realms of infrared, radar and more, capturing data across the electromagnetic spectrum. Each sensor captures tiny measurements, pixels, the fundamental building blocks of a satellite image, each representing a specific patch of Earth, a small area reflecting the characteristics of the land below, filled with data about color, revealing the composition of the surface, temperature, indicating heat signatures and thermal properties, and texture, providing insights into the physical structure of the landscape. These individual pixels are then meticulously assembled into digital images, a process of reconstruction and interpretation, creating a rich tapestry of our planet, capturing a snapshot of Earth at a specific moment in time. Satellites provide continuous, silent observation, tirelessly monitoring our world day and night, building an invaluable archive of Earth's changes, a historical record of our planet's evolution. They track the alarming rate of shrinking ice caps, providing critical data on climate change, expanding cities, documenting the rapid pace of urbanization and its impact on the environment, and shifting climates, offering crucial insights into the complex dynamics of our planet's weather patterns. Remote sensing gives us the big picture, a comprehensive view of our world, insight into patterns and changes, revealing trends and anomalies that would otherwise go unnoticed, invisible from the ground, offering a unique perspective that transcends the limitations of terrestrial observation. It's our window to the world's transformation, providing the data we need to understand and address the challenges facing our planet. With this extraordinary data in hand, how do we make sense of it? Enter digital image processing. Think of it as a digital darkroom where computers refine and analyze satellite images. By manipulating pixel values, we extract hidden information, teaching computers to recognize forests, water, or cities by their unique numerical signatures. This process turns images into powerful scientific tools, enabling precise measurement and analysis. The subjective human eye is replaced by objective, repeatable calculations. Digital image processing bridges the gap between raw data and real-world application. It's how satellite imagery becomes essential for understanding and protecting our planet. The journey from raw satellite image to useful map begins with pre-processing. This crucial step removes errors and distortions from images captured hundreds of kilometers above Earth. Noise, random electronic interference must be smoothed out and missing data intelligently filled. The atmosphere scatters and absorbs sunlight, altering true colors. Atmospheric correction digitally removes these effects. Geometric distortions from the satellite's movement and Earth's curvature are corrected, so every pixel aligns with real-world locations. Pre-processing ensures images from different times and conditions can be accurately compared. Only after this digital canvas is cleaned and primed can real analysis begin. Without it, any conclusions drawn would be unreliable. Pre-processing is the foundation for all meaningful satellite image analysis. It prepares the data for the discoveries to come. Let's look closer at the two pillars of pre-processing: radiometric and geometric correction. Radiometric correction ensures pixel values match the true brightness and color of ground objects, even under different lighting or atmospheric conditions. This calibration is vital for accurate scientific measurement and comparison over time. Geometric correction aligns every pixel to its correct map location, compensating for satellite movement, Earth's rotation and terrain. Scientists use ground control points, like road intersections, to mathematically warp images until they fit maps perfectly. This process, called orthorectification, turns images into accurate maps. With these corrections, satellite images can be integrated with other geographic data. Without them, images are just pictures. With them, they become powerful, reliable maps. These corrections are the backbone of trustworthy remote sensing. With a corrected image, we move to the heart of processing, the stage where raw data truly begins to transform. This is where the real insights start to emerge. Extracting useful information. We're not just looking at pretty pictures anymore, we're actively pulling out meaningful data that can be used for a variety of applications. Image enhancement techniques, like contrast stretching, are crucial at this stage. Reveal hidden details by expanding brightness ranges. This allows us to see subtle variations that would otherwise be lost in the noise. False color composites assign visible colors to invisible wavelengths, opening up a whole new spectrum of analysis, making features like healthy vegetation stand out. This is particularly useful in agriculture and environmental monitoring. Image classification trains computers to categorize pixels, a process that's fundamental to understanding the composition of the Earth's surface: water, forest, urban, farmland. Each category representing a distinct land cover type, based on their numerical signatures. These signatures are unique to each type of surface, allowing for accurate identification. Supervised classification uses known examples. We teach the computer what to look for. Unsupervised lets the computer group pixels statistically. It identifies patterns without prior knowledge. These techniques turn qualitative pictures, which are often difficult to interpret directly, into quantitative maps, providing a clear and concise representation of the data, showing precise boundaries and areas. This level of detail is essential for effective resource management and planning. We can measure deforestation, tracking the rate at which forests are being lost, urban growth, monitoring the expansion of cities and their impact on the surrounding environment, or water bodies with accuracy. This helps us understand changes in water availability and manage water resources effectively. Classification automates what would be impossible for humans alone. It allows us to analyze vast areas quickly and efficiently. It transforms satellite data into actionable knowledge. This knowledge can then be used to make informed decisions about our planet. This is the true power of digital image processing. It's a tool that empowers us to understand and manage our world. It reveals the story hidden in the pixels, unlocking insights that would otherwise remain unseen. Classification unlocks one of satellite data's most vital uses, change detection. By comparing classified images from different times, we can map exactly what has changed: urban growth, deforestation, glacier retreat. City planners see new development, scientists track environmental shifts, responders assess disaster impacts. Change detection provides clear, visual evidence of trends too vast or slow to see from the ground. It's used to monitor illegal logging, wetland loss and more. By revealing what's changed, we gain insight into our impact on the planet. The satellite becomes a time machine, showing the unfolding story of Earth. It's a powerful tool for science and stewardship. The final step is delivering results in a clear, actionable form. Thematic maps distill complex data into simple visuals, like wildfire risk or soil moisture, using intuitive color codes. These maps communicate science to society, guiding decisions and policy. Sometimes the result is a report or statistics, crop yields, damage assessments, derived from processed images. Increasingly, results are shared as interactive services, weather apps, online maps and real-time data layers. This democratizes remote sensing, putting its power in everyone's hands. Farmers, planners and citizens can all use satellite insights. The journey from raw pixel to useful tool is complete when it empowers people. That's the true value of satellite image processing. We return to our initial puzzle, the blurry postcard from space. Through digital image processing, that confusion becomes clarity and knowledge. Pre-processing cleans the canvas, ensuring images are accurate and comparable. Processing interprets the data, revealing forests, cities and changes with precision. Delivering results as maps and reports puts this knowledge into action, helping farmers, responders and scientists. The impact is everywhere, managing resources, protecting ecosystems and building a sustainable future. Digital image processing is the bridge between technology and understanding. It translates the silent language of space into a compelling narrative about Earth. It gives us new sight, a perspective both vast and detailed, and it empowers us all to be better stewards of our world.